Yeah, it is. Wait, this is my security, not your security. This is follow each other down. Oh, my black lights. Yeah, hey, Tom, make sure to put your phone. Are we there? Oh, yeah. Chow, make sure to put your phone up. Chow, make sure to put your phone up. Oh, that would not, I would compare it.
Like that.
What?
Yeah, it's like.
Okay. Because they gave me carrots today, I was like,
Oh,
oh,
no,
this
good,
is
good,
tough.
good. Good. Last time though.
Okay.
I don't think you're on the game now. I have that. I don't think he's now. Thanks. No, no, read this all. What? Trading.
And then it turned a little chilly. There's context to that, I swear.
Oh, he's one of. He's never been like. Right.
No.
They give me a price that you put a pile on day.
Hi, how are you? I'm good. How are you?
I'm Sal.
Hi. Oh, no.
Talbot.
Hi, how are you?
I'm good, how about you?
Good. Hello. Hey, sit, stay. Thank you. I'm gonna say it after I teach you guys. The notes are not gonna take all period, even not even close. So I will stand after while you guys are working on homework. So if you could just get this going for me. I said I'm gonna stamp after I teach. Because of the tsunami? I'm kidding. Joking. I'm joking. Okay. All right. Definitely not gonna talk all the way through my lecture, but it's gonna be great. If we made our commitment to ourselves not to do that, when we walk in the door. Okay. Now. First section we did was the M&M's day. So I want us to think back to the M&M's situation. We made a bar graph with the different proportions of M&Ms that the Mars company claimed within the entire population. Do you remember that? It was like 25 and 25, and then like 12.5, 12.5, 12.5, 12.5. Remember it? Okay. That was the graph of the population. To be honest, is it the real graph of the population? It's just what they claim, but you can picture M&Ms coming off of the factory every minute, probably changing it up a little bit as time goes on. Okay. Then, right underneath that, we did a graph of just your sample of 20 candies, and we calculated how many out of 20 was in each color, and you made the little bar graph underneath. Remember? Okay. Then, you gave me all of your proportions of blue M&Ms on the blue sticky notes. And we graphed that on the dot plot. You remember? Okay. Now, can you imagine all of the samples, all possible samples from the whole world of 20 M&Ms? So think of Dixie cups of 20 M&Ms. All possible samples from the whole world, calculated the blue proportion and put on a dot plot. It's kind of hard to imagine, right? Okay, what we're going to do today is talk about what would that look like. We can't make it, it's impossible. What would it look like? We can actually make some assumptions about it compared to just compared to the sample itself. Okay, so I have a question. If we're going to describe something, like let's picture a dot plot, a beautiful dot plot of all the M&Ms, right? You see it? Gorgeous, gigantic dot plot. Okay, there are three things that we use to describe a distribution in this class. We learned them in chapter 1. What are those three things? When I say describe, what? Shape, center, and spread. And outliers in this case is you're not wrong. It's just that if it was perfect, there wouldn't be any. Okay, so because it would go from like 0 to 100%. Okay, so shape, center, spread. Okay, so these are the things that we need to determine. We're going to do backwards stats magic, which means I can actually tell you some stuff about the sampling distribution just from a sample. We're going to start with shape. What do you guys think the shape of it would be? Do you have a guess of what it might be if it was perfect? Yeah, great job. Okay, so the shape uses the large counts condition. If n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10, okay, you already learned this last chapter, large counts condition. So we used it for the binomial approximation to normal, and we use it for this too. So and think about that proportion of evidence kind of being related to being binomial. But we're going to just perform a calculation. So when it says what's the shape of the sampling distribution, you're going to go, okay, shape. I want to see if it's normal. Normal means large count. So NP is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. If those are both true, you put normal. If they're not true, look at the graph. If they give you one, and say what the shape is. If they don't give you a graph, you're just going to say not normal because it didn't meet the conditions of the large counts condition. Does that make sense?
Yeah.
Okay. You might not know the shape. It might just be not normal. You just might know that. you don't know what kind of skew it has or anything, it's okay. Okay, are you guys good with shape? Okay, what's the next thing? Center. Yep. Excellent question because did I tell you guys that the Zoom upgraded? So I like it like downloaded itself a whole new version and now the little recording thing disappears after a minute.
Pick in the top right.
Yeah, but I had to move the mouse for it to do that. Anyway, just watch, it'll disappear in a minute. Okay.
Oh.
So center. I'm really glad you asked, by the way, and you can always ask because it's important to me that it is going. Okay, center. So the center is going to be the mean, and I'm going to use the symbol mu because we're thinking about this being perfect. Is our stuff ever really going to be perfect? No, probably not. But this is kind of like a mathematical model of all possible samples. What? Is everything okay? Okay. Did I say so? Okay. Anyway, so we call this the mean of p hat. Okay, so pause real quick. Flip back to your, oh, hey, it's right here. Okay, so when I say the mean of p hat, I would mean the average of all of these. And where do you think the average is-ish? 0.2, 0.25. Okay. Now, what do we know about 0.25 in this problem?
Oh, and that's the proportion that they said.
Yeah, that's the proportion that they said. Okay, I don't even know if I can tell you the importance of this moment in stats. This is the backward stats magic I was talking about. So you could use this to be like a slide. So you could say, all right, I wonder if they're putting way too many blue ones in the bags. Like, we don't really care, but let's pretend we care. Let's pretend we had all the time in the world we cared about blue M&Ms a lot. Okay, you could get a lot of samples of size 20. There's a lot of them. You see the hand, I mean the lot, okay? And then you could find the middle of it, and you could use backward stats magic to go, oh, then the company must be putting in about 25% blue. You can get that information just from samples. You don't have to go back, you don't have to actually know the real number. You can just estimate the number based off of your sample. That's the whole reason that this class is a class. Okay, and I can leave now because the class is open. No, I'm kidding. But like,
Oh, no.
that's the whole point. The whole point is sometimes it's impossible to know the real number, but you can get what you need anyway, just from samples. Okay, so I know you guys are just gonna tease me because I'm all geeked about it, but so okay. So the mean of that dot plot should be the true population proportion. So let's write this in words. I'm so excited about it, I can't write. Okay, spread has a formula and it's standard deviation, but you have to check the 10% condition works.
first. The formula only works if it meets the 10% condition. So let's just write that first and then let me remind you what that is. You guys all know that symbol as standard deviation, correct? Okay, now we're gonna go through this stuff with an example. And the example is gonna be our M&M data, which is great because then you can use your Post-it flag to flip back and look at that picture as we go through our work. Oh man, Mrs. Talbot, you and your Post-it flag. Organized here. Uh, soon? Yeah. Okay. So we're gonna do this problem and we're gonna flip back in the book and look at our graph from the previous page. Okay, starting with shape. Shape. You know, it would be really smart actually before we start this problem to say what N and P are. What was the size of our samples in our Dixie cups? Yep. Okay. So just over here, I'm going to put N equals 20. And what was the true? Okay. The true proportion is 0.25. Okay. That's all we need to do all our maths. Okay. Shape. We're going to check the large counts condition. N times P. 20 times 0.25 greater than or equal to 10. And 20 times 1 minus 0.25 greater than or equal to 10. This side, 20 times 0.25 is 5. And this, I don't even need to do the math because they have to add up to 20. Is 15. For it to be normal, they both have to be greater than or equal to 10. So, not normal. Okay, now, take a look back at your graph, your dot plot from the first day of your M&Ms. Check what you think the shape is. Right skewed? Yeah. So that kind of backs up our information. Now we need to take that with a grain of salt. Why? Yeah, we only had 30 samples. Not all possible samples. All possible samples would be a lot more dots. So we have a small amount of samples, but anyway. Okay, now if you did not have a graph provided for you, you would just say not normal and you would stop there. Does that make sense?
Mhm.
Everybody good so far? Okay, center. The mean of that dot plot should be 0.25. We discussed that already. Does it make sense that the center of it is about 0.25? Yes, Anita.
You might say this already, but why are we always using mean? I feel like I know you're considering mean.
No, that's not a bad question. I think it's because our goal is to use normal CDF at some point, and so you want low, high, mean, standard deviation. But there should be really median in this one, right? Because it's skewed. Median would be a better choice. However, I want to make sure this is an excellent question. Excellent question. Our graph that we made wasn't the whole sampling distribution, it was just a little piece of it that we got from our 30 samples. What I'm saying here is the real one would have its center at 0.25, and we would know that for sure. But we don't really know for sure what the shape is, because we only had our 30 samples. Does that make sense? So we don't call it the sampling distribution, we call it the approximate sampling distribution. Just want to make sure. When I talk about mu, I mean the perfect one. Like this is the perfect graph. Okay. Spread. All right, so the first thing we need to do is check the 10% condition. So our sample size was 20. Do you think that 20 is less than 10% of all M&Ms everywhere in the whole world? Okay, just for reasonableness sake, let's round this to 0.1 in our minds. Flip back to your dot plot one more time. Would it make sense that the standard deviation might be 0.1? Yeah, I think so. So center at 0.25 and then standard deviation of 0.1. I think those are very reasonable answers. Okay. Any questions before we move on? You sure? You're all good? Okay. Oh, cripes, I didn't bring you the stuff. It's already passed. I don't believe that this is the last example already.
How with that mentality, you know? Stay on the one. Okay. This is gonna be a close one. This is gonna be a close one.
Friend.
Wait, if you guys bear money, right? I don't know if you want- if bear money, I'll have to-
It's like up to one.
I think we do. Yeah, I can say that. But like, I still think it's full. I always want to be full. I still think. Ten minutes not, that was like a step. I know.
Oh. Well, the example is.
Oh, don't worry about it.
Are you guys ready? Okay, I sort of spoiled this because Jake asked that excellent question. And now you can see here that it's asking to find the probability. And so the goal is to be able to use Normal's PDF. So we need to be able to get everything that we need to plug in the low, high, median, and standard deviation. And we know because it says find the probability. So that means we want to get a problem. We want to do a problem where we find the area under the normal curve. Okay. First thing we're going to do is shape. Okay. What should I do? Okay, which one of the numbers in this problem is n? And if you want to, if it helps your brain, just throw n over there. And what is p in this problem?
35.
Okay, so n times p. N times 1 minus p. Okay, you guys go ahead and yeah, calculate this, see if it's normal. Hopefully it is, because that's all I'm banking on right now to be able to do the problem. So 525. Okay. So that means this has to be 975. Okay. That like unlocks normal CDF for us. So now we can use it. Okay, now we need the mean and standard deviation for that. Okay, what's the center of that dot plot going to be at? Look back if you need to. 0.35? Yeah, it's not so sweet. Did you get, are you overthinking?
Yeah.
Okay. Okay, so you think that there's more than 15,000 first-year college students? Yeah, definitely. Okay,
I got 0.0123.
all good, all good. Okay, now we're gonna do the probability. We're gonna use proper random variable notation. And the hint for the low and high is right here. So it says random sample that will give a result within 2% of the true value. The true value is 0.35, so that means your low is 0.33. And your high would be 0.37. Do you see where that came from? The plus or minus 2%? Okay. Okay, now in this case, you don't need to label anything in your parentheses because your random variable notation takes care of the low and the high, and your mean and standard deviation are labeled up here. Now make sure that you know our normal CDF is in the calculator. Oh, there's a 90% chance that the true result is between 33 and 37%. It makes sense. Okay. You have any questions right now?
Now can you get out your yellow sheet, please? One that's yellow. Okay. This is the last text in which you can use a note card. I said it the first day of school, it's in the syllabus. Okay, and the reason is because I need you to get used to using this instead. We're going to write stuff on here as we go. Then you'll be allowed to use this on your test, but you can only write the things that we've all written together. Can't add a bunch of extra notes in the margins and whatnot.
Yeah.
Okay, so I want you guys to look at the back. And the top line. And this is what we just learned today. So random variable for one population p hat. So this says sampling distributions for proportions. P hat is your sample proportion. We just learned this. The mean of that dot plot should be right at the true population proportion. Ours was 0.25 for the M&Ms. And the standard deviation is square root of p times 1 minus p over n. Okay, now what is this? This is an estimate that we use when we don't have p. And we're going to get into that later. But for now, if you want to, and I highly suggest while you're doing your homework, refer back to this page and find these and look at these. What are those formulas again? Find them on the page. Make this like sheet your best friend. Have it out when you're doing your stats stuff. Let's take a look at the other side. This top two things are things that we've done so far. This is the formula for the mean. This is the formula for standard deviation. We get those off of our calculator from one variable stats. Mostly we do not use these. These three, do you remember these three? These were the line of best fit. So least squares regression line. And then to the perfectly average point, and then how to find the slope. And this one we never used really. We got R from our calculator when we did linear regression A plus BX. What chapter is this? 3? I'm just showing you this because, you know, at some point. Yeah. Okay. Yeah. Yeah, this is the exact sheet. These two are from the probability chapter. So they gave you the general addition rule for OR, and they gave you the conditional probability rule. And then this part is from chapter 6 that we just did. So this is the top times the bottom, top times the bottom, top times the bottom thing. And this is the like x minus the mean squared times the bottom thing. There's the binomial formulas and there's the geometric formulas. You don't know any of the stuff down here yet. And then the only things you know on this page are these two that we just learned today. So anyway, keep this guy handy. Just start using him, getting him out. And use him on your homework so that you know exactly where stuff is.